Okay, welcome guys to our AP Calculus course. In this lesson, we're going to cover in lecture number 17, we're going to cover integration or antiderivatives. It's just a basic introduction and remembering the rules from previous lesson number 6 and 7. If you remember differentiation rules, you'll be able to solve most of these problems. So assuming that you remember we had, just say we got f of x function. Let me start with the f of x function because it's an introduction. If I have x cubed minus 5x squared plus 3, what is the derivative of this? It's a simple polynomial function. If I try to find the derivative of this, I will get 3x squared minus 10x, right? Plus 0, because the derivative of the constant is 0. Now, what does antiderivative do? You have f prime x, you want to get back to the original function. So this is an antiderivative or an integral. This is an antiderivative. In other words, I have the derivative, I want to find the original function. So just creating a problem. This is 1a. So b, I want to solve the antiderivative of f prime x. F prime x is 3x squared minus 10x. So what is the original function? F of x. You need to add 1 to the power, because when you differentiate, you subtract 1 from the power, okay? So when you integrate or when you do
One
the
question, Mr. Ghazali,
antiderivative,
sorry.
yes,
Yeah.
yeah.
But how we can find the constant if, for example, it's always zero in the integral? How we can find from the differentiation rule to the original one
Yeah,
if you don't know the
good.
constant?
All right, good question. So you're just going to put plus c. So look at this. We got 3, add 1 to the power, x cubed divided by 3. You need to divide by the same power. Subtract 10x squared divided by 2. So you have to put a plus c here. Okay? Because remember, this value is 0. How you get 0? When you differentiate a constant. Does that answer your question?
Yes, sir, thank you.
So x cubed minus 5x, we are just simplifying now. 5x squared plus c. Right? So this is my antiderivative function, original function. You had the derivative, now you're finding the antiderivative. Sometimes they tell you the derivative is f of x, is like this. What if they give you the derivative as f of x function? So if you want to find the bigger function, you call it capital F of x. Use capital F of x, all right? So they will give you something like this. 5 over x cubed minus x to the power 5 over x cubed minus square root of x plus minus say plus 3x cubed plus 2x minus 1, for example this. So this is the derivative function, right? What is the antiderivative function, which is f of x? So how are we going to solve this? We can't really solve it directly because we need to put it in power rule form. Okay, so we're going to put it in. So this is where the power rule comes in, because you don't know the rule. What we have done is we have reversed the derivative into an antiderivative. So we need some rule in order to solve part C. So what is the rule? Rule number 1 is called the power rule. Right. So what's the power rule for antiderivatives? All right, so going back 1 second before we do the power rule, look at this, look at these functions. What's the notation for antiderivative? What is the notation? So same example, I can also write it out like this. Note, same example, I can write it out like this. So the notation is the integral. You see, it's a curly s, right? The integral of, it's like this. You can draw it in many forms, right? So the integral of, or the antiderivative of, x cubed minus 5x squared plus 3. Oh, sorry, 3x squared minus 10x, right? 3x squared minus 10x dx, right, is equal to, you're not going to come to the exact answer of plus 3, because what we are doing here is you're going to get a plus c. So remember, to write this out, we're going to say the integral of 3x squared minus 10x, and we are integrating with respect to the variable x. So we had an answer of x cubed minus 5x squared plus c. That's a notation, right? As you can see here. So, okay, we did it in this example. So let's paste it down here. All right, great. Because the first example was just covering differentiation. So there, that's your answer. That's another way of writing it out. Okay. Now, so we need to have some kind of a rule to reverse the derivative or find the antiderivative. So the rule is integral of x to the power n, constant times x to the power n dx. Okay. So you leave the constant as it is, you add 1 to the power, right? And you divide by the exact same power plus another constant. So let's call this constant k, right? I can't use this two same c values, use a different constant k, leave k as it is, add 1 to the power, divide by the same power. So that's the power rule for integration. So that's what I'm doing here. I'm trying to use the power rule to solve this, right? So to find f of x, you need to say that's the integral of, try to simplify all this. This is 5x to the power negative 3 minus x to the power half plus 3x cubed plus 2x minus 1, right? dx. So you are integrating this. Now we have it in power rule form. So we're going to say this is equal to 5x to the power negative 2 because we're adding 1 to the power and you need to divide by negative 2. Divide by the power minus add 1 to the power was half plus 1. Remember, when you differentiate, you make the functions smaller. When you integrate, you make the functions bigger. Okay, so x to the power half, you say x to the power 3 over 2 divided by 3 over 2 plus 3 x to the power 4 divided by 4 plus 2x squared divided by 2 minus 1x, because this is x to the power 0, plus always add a constant. Why are we adding a constant? Because you see, this is just a general indefinite integrals. Okay, these are for indefinite integrals with, yeah. So these are indefinite integrals that we are finding. The integral sign that you have on the calculator calculates definite integrals only. So let's simplify this. This is negative 5 over 2. And the x to the power minus 2 goes down, x squared. This is 1 divided by 3 over 2 is 2/3. X to the power 3 over 2. This is 3/4. X to the power 4 plus x squared minus x plus c. How you know your answer is correct? You can differentiate this and you will get the inside of the integral, which is called the integrand. Okay. Okay, the entire thing is an integral and this is the integrand. Are we good, guys? Make sense?
Yeah.
So why did you
Right.
differentiate it twice?
What do you mean I differentiated it
When you're
twice?
solving the integral, the first one is correct. You don't need to expand it to the second one.
I have to put it in power rule form. I'm integrating this. This is the derivative function. This is the antiderivative function.
I know how to integrate. I'm just saying, why did you put it in the power form?
I have to put it in power form because it's the power rule.
Okay. Yes.
Power rule means put it in power form. You know, like when you differentiate, you have to put it in power rule form. That's the form I need it in. Right. So now let's take a second example here.
Sir, sorry. In this case, are we using power rule because it's the simplest, or is it the only way to solve it? Solve a question like
Yeah.
this.
You see, every time you have a derivative, every time you want to integrate or you want to find the antiderivative, you try to use power rule
As much as possible, right?
as much as possible. That's
Okay,
like
unless
your
it's
cone
trig
rule
like
rule.
sine and
Yeah.
cosine and secant.
Even trigonometric rules sometimes comes to power rule when you substitute.
Yeah,
We'll do that in tomorrow's lesson. But for now,
yeah,
let's
like use
focus on,
substitution and everything, right?
yeah.
Yeah. Okay, okay.
Are we good with the power rule here?
Yes.
Right, great. Now, next rule, remember what we did here? We did something called an indefinite integral. I will do definite integrals, but not now. Let me do some examples here. Yeah, okay, let's do definite integral as well. What's a definite integral? Definite in number 2. Definite integral. Now, definite integral is something that you apply in the real world, all right? And you actually get values for. It has meaningful values. Right, so definite integral is basically integral a to b of f of x dx. Right. Now to find integral a to b of f of x dx, that's just basically equals to capital f of b minus f of a. F of b minus f of a. In other words, you're going to get the function f of x, right? Big F of x. After integrating this, then you substitute the upper boundary minus the lower boundary. Now, the upper boundary and the lower boundary does not necessarily mean it's a bigger value and a smaller value, okay? Because in trigonometry, it can change. Because when you do change of boundaries, it changes. It's just upper boundary minus lower boundary. That's it. Not upper value minus, don't learn it like that. It just, yeah. So it's the upper boundary minus the lower boundary. Are we good? F of b minus f of a. But remember, this is the last part. So how are you going to do f of b minus f of a? First, you need to integrate it, right? And obviously, you're going to block it out and put f of x inside here, right? And then put a and b. You substitute b, and then you substitute a, and you minus, right? That's a substitution block. Anyways, let's take an example. Now, what does this here mean? What is the meaning of this? The meaning of this is that it represents an area under curve. Remember, I'm not going to do Riemann sum now. I will do it at a later stage where we use rectangles and stuff to approximate the area and then find the exact area. For now, what does this definite integral represent? So if I have some curve like this, if I have a curve like this or any other curve, it just represents, let's just say, maybe a cubic function, right? Whatever. And you're trying to find the area between A and B, right? Now, remember, no geometrical figures can actually solve this. So that's where integration comes in. All right, so I want to find the area between A and B. I want to find the area under the curve, right? And this is some function f of x. Now, how do we find this? There's it here. That represents the area. So area is equal to integral a to b of f of x dx. Let's take a basic simple example, right? So I'm going to take a basic simple
One
example,
question.
which is, yes.
Mr. Ghazali, sorry, one question. For
Yeah.
example, for the finding area, we should put the 2 points between which we want to find the area, yeah?
Yes, correct.
Or if we will not put the points, it will go to the infinity?
It depends how you're finding what's the lower boundary and the upper boundary. If you don't put the 2 points, then you're just finding a general indefinite integrals. Indefinite integral means infinite. Yeah.
Okay,
It can
okay.
be positive infinity
thank
or negative infinity. Yeah. If you don't put the boundary, you know what he's
yeah,
asking for. But you see, whenever you're finding area under graph, there has to be 2 points. because you're finding an area, it has to give you some kind of value. Okay, so now let's look at a basic example of a triangle, right? A basic example. All right, so I'm taking an example here, but I won't take a triangle, I take a trapezoid, okay? So I'm trying to find an area under this, right? So this line goes through 2, and the next point is here, somewhere around here, right? This is x-axis, that's the y-axis, and there's a 0 line here. This is 5, right? And that point is 4. So I want to find the area under this. Is it possible to find it? Yes, we can, because we can just draw a line
Riemann
here.
sum.
No. See now, I just told you I'm doing Riemann sums another day. For now, I just want to use the integral laws. So see, we can divide it into 2 parts, right? So we have a triangle here. What is the distance between 4 and 2? Remember, I said this point is 5 and 4. So the distance that we have from 0 to 5, that's fine. From 5 to there, there's a rectangle and a triangle. So the area under this graph is base times height plus, sorry, length times width, because we're looking at rectangle. Area of rectangle plus area of triangle. Area of rectangle is 5 times 2 plus half. Area of triangle on top is half base times height. What's the base? Base is 5. And what's the height here? 2. Because from 2 to 4, the height is 2. Right, so I've got 10 plus 5, 15 units squared. Are we good? Guys, you understood this? Now, how can I apply integration in this example over here? To apply integration, I need the function. I need this function over here. What is that function from 0 to 5? What is that function 0 to 5? So first we need to find the slope, okay? What's the slope? Y equals mx plus c or ax plus b or whatever, you know, right? So I need to find this function. What is the slope? Change in y, the slope is 2, and change in x, the horizontal is what? Horizontal is 5, right? So 2 over 5. Are we good? So
Wait,
f of
sorry,
x,
mister, what are you doing? What?
I'm finding
Slope of what?
I'm finding the slope of this line here from 0 to
Oh,
5.
of that line. Okay, yeah, 2 over, yeah,
The
okay.
highlighted line.
Yeah, the highlighted line. Okay.
There's my function, right?
Yeah.
So the slope is 2 and the horizontal is 5. So 2 over 5x. And what is c? Y-intercept
C
is
is
2.
2.
Yeah, so I already have 2 as a y-intercept. If you don't have the y-intercept, then you need to find, put the equation in slope-intercept form, or point-slope form, and then you can get the value for c. You know how to do that. Now, remember, values, x is drawn from 0 to 5. I want to find the area from 0 to 5. So easy.
Mr.
Area
just do
equals,
the definite integral from 5 to 0 of 2 of 5x plus 2, right?
oh, hold on. You read it incorrectly. You say 0 to 5. Integral
0 to
from
5.
0 to 5. You don't say 5 to 0.
My bad.
Right, so over 2 over 5x plus 2 dx. Right, so now we're going to integrate this. So you're getting 2 over 5, leave the constant, x to the power 2 over 2 plus 2x. Now you don't put a plus c, okay, because it's definite integral. So this is from 0 to 5. What is 0 to 5? X equals 0 to x equals 5. That's why you substitute into x. So let's take this out now. The 2 and the 2 is out. I'm going to substitute 5 inside the place of x. So I got 1 over 5 times 5 squared plus 2 times 5, okay? That is substituting the upper boundary inside here, right? Inside the capital f of x function, the antiderivative function. Substituting 0 inside is just 0 plus 0, because you're multiplying 0 squared times 1 over 5 and 2 times 0 is 0. So If I
So we
simplify
get the
this,
same answer.
yes, of course, you will get the
Yeah.
same answer.
25
So
over 5 is 5 plus 10.
plus 10. So we're getting 15
15
units
units
squared. Yeah, great. Right, so we're getting the same answer. So at least you understood what that is. Now remember, can I do this on the calculator quickly to double check my answer? Of course you can. So let's go and open the calculator and see if we can actually do it. So we say integral, there's your integral sign. Please type properly, put brackets and stuff. So that's 2 over 5, right? Alpha x, alpha x squared. Oops, supposed to be on the inside. Alpha x squared plus 2. And as you move the cursor left and right, then you'll go to 0, and the upper boundary is 5. Check. It wasn't 2 over 5x squared. Watch.
I'm you did it wrong.
Yeah, it's supposed to be 2 over 5x. I put x squared. Why did I put x squared? You didn't even tell me. Let's say x to the power 1. The answer is 15, okay? Are we good? Let's correct it properly. Alpha x. Okay. Great. So we got the answer, right? Now, you can solve every single definite integral like this on the calculator. You know that. Any functions you can put inside here, you can solve it on the calculator. That's the advantage of this. And lucky you are allowed to use a calculator, which is great. Right, so there, we get the same answer. So I showed you many ways. Now, let's solve some examples. Now, the third part is I want to solve, hello?
Yeah, sorry, just I want to ask one thing. So right now we find the area under that, yeah?
Yeah, we're finding it. I'm just telling you what a definite integral is. It's like finding the area under a function. That's it.
Okay.
It doesn't. Now, why does, you see, it works for a triangle, so it will work for all curved function. You see, in triangle, you can use geometry, but in a curve, you can't use geometry to solve, okay? So there's it here. So now number 3, I want to look at trigonometric integrals. Just the basic ones, okay? So what's trigonometric integrals? You need to just remember the simple table that I taught you. Sec, sec, tan. Remember that one for derivatives? Cosec, negative cosec, cot. So if I ask you what's the derivative of sec?
Cosecant, yeah.
Sec tan, sec x tan x. Derivative of cosec, negative cosec cot. Derivative of tan, negative 6. Derivative of tan is 6 squared x. Derivative of cot is the other two. So if it's the other two, how does this table help us? This table helps us to integrate in pairs only. Integrate, very important. Integrate in pairs. So what's the integral of sec times sec? What's the integral of? You see, I'm taking a pair. You can't integrate singles. Then you're going to end up with problems. So what's the integral of sec squared x? Integral of sec squared x. It's a pair, right? Sec sec. That is just tan x plus c. Are we good? Next one. What's the integral of sec x tan x? Integral of sec x tan x is sec x plus c. Are we good? Sec tan. I took a. I'm left with the other one. Next one. What's the integral of cosec squared? Is negative cot.
This is negative CSC plus cot.
Yeah, because you see, I didn't take a negative cosec squared. So I just took cosec squared x. So it's negative cot x plus c. Next one. What's the integral of cosec cot?
It's negative CSC.
Yes. Plus a capital C. Are we good, guys? That's how you apply the
Wait,
table.
sorry, mister.
So
Why did we put negative? Oh, okay, you said positive. Okay, never
yeah,
mind.
because I didn't take the negative out here.
Yeah.
If you take a
No, I
negative,
thought
it's
you
just a
said
negative
negative
one.
cosec. Yeah, okay.
Uh-huh.
Got you. Got you.
Now, now we have a problem because, oh yes, one more thing. For trig integrals, you also need to remember the most fundamental is this. You have to remember that the integral of sine x dx is equal to cos x. You have to remember this. This is fundamental.
Can you make it reversibly? Cos
One second.
cos x equals to sin x.
Derivative of cos is no. So wait, integral of cos x. Sorry. Integral of cos x dx is sine x plus c. Because if I differentiate sine, I get cos. So integral of cos is sine. And integral of sine x dx is equal to negative cos x plus c. Very important, because if I differentiate cos x, I will get negative sine. So if I differentiate negative cos x, then I will get sine. Are we good, guys?
Yeah.
Make sense? Right, great. Now, what's used together with trigonometric integrals is also something called a log integral, right? Now, you remember the power rule?
Yes.
Now I'm going to fail the power rule, right? So we're going to say, what's the integral of 1 over x dx? Try power rule here. We're going to say integral x to the power negative 1 dx. Add 1 to the power. How are you going to integrate this? If you add 1 to the power, you're going to get x to the power 0 over 0 plus c. But you can't divide by 0. So this rule is
Mr. The
definitely
integral
incorrect.
of this is ln x plus c.
Good. Ln absolute value x. So that's why we say the integral of this is ln absolute value of x plus c. So what's the integral of 1 over x? So now we can go back to the power rule and say power rule will always work whenever n is not equal to negative 1. As long as n is not equal to negative 1, the power rule will always work. If n is equal to negative 1, then it will become ln x. So in other words, what's the derivative of ln x? 1 over x. What's the integral of 1 over x? Ln x plus c. Are we good, guys? You understood that? So what is this? Power rule fails. So what rule is this now? This is the log rule. In other words, the natural log rule. That's what number 4 is. Not power rule, the natural log rule. So what did we learn from here? That the integral of 1 over x dx is this. Are we good? Make sense? Excellent. Now note,
Yeah.
we have to learn another technique of integration. The second technique of integration that we learn is something called a U substitution. It's a technique of integration, not a rule, it's a technique. So let me just call it option 5, right? So what's the technique? U substitution. What is a U substitution? U substitution is something that we need to apply when we have something like this, when we want to integrate integral of 2x, let's just say integral of x minus 10 or x minus 6 to the power 20 dx. Are you really going to use binomial expansion to expand this 20? Huh? No, you're not.
No.
So how we
No.
solve something like this? Yeah. How we solve something like this? We apply something called a U substitution. So let's apply. Now I'm going to do about 3-4 examples on U substitution here because I need to apply it to trig. Okay. So what's the technique? U substitution. So how do we apply this? So we say let u equal to x minus 6. And now you find the derivative. Say what is du dx? It's just 1. What's the derivative of this? 1. Now you take the dx, you cross multiply. So you say du is equal to dx. So the only thing in future, I'm not going to write du dx. I'm just going to differentiate both sides. I say this is du and that side is dx. All right. So
Mister,
what's important here is that this is equation 1 and this is equation 2. You have to take equation 1 and 2 and transform this entire integral in terms of u. So call this the integral. So the integral now becomes integral of what is dx? Du. Isn't what is dx? Du. So this part is done. What is x minus 6? U to the power 20. Are we good?
Yes.
And what rule do you, and what rule do you come back to? Our rule. Make sense?
yeah, Mister.
Yeah.
Why does du over dx equals 1?
Because the derivative of x is 1.
Okay.
You're differentiating with respect to x, right? This is x to the power 1. 1 times 1 is 1. X to the power 0. Derivative of constant is 0. So it's just 1. This is a linear function. What does du dx means? What's u prime? It means what's the slope of this function here? 1. If I have u equals 2x minus 3, what's the derivative of this? What's du dx? 2.
Oh, okay, got it.
So it's like d
Or you
dx
can-
or dy dx, right?
Yeah.
Okay,
Instead of
okay.
yeah, I'm not doing y substitution. It's called a u substitution. So let me just stick to the
Okay.
variables. All right.
Yeah.
So now let's simplify this. It's already simplified. Now what do we come back to? We come back to something called what? A power rule. So this will become u to the power 21
Yeah,
over
over
21 plus c.
plus c.
But what was u? U was x
U
minus
was
6 to the
x minus
power.
6.
Yes. So we got 1 over 21 into x minus 6 to the power 21 plus c. That's my final answer. Great. Understood that?
Yep. Okay.
Right. Right. That's basically u substitution. Let me give you another example because example 2 on u substitution 5.2. Integral of 2x squared minus 5x. Okay, let's just say 2x squared minus 5 to the power 6, right? And I have x on the outside, okay? So you always make the one that's looking uglier to u. So u substitution, make this one in the bracket equal to u. So you say let u equal to, call this the integral, okay? Let u equal to 2x squared minus 5. So what's du equals to? Let me put the dx across as I told you before. Is du over dx. I just put the dx across, right? So differentiate this.
4, yeah?
4x. Good. 4x.
Oh, yeah, 4x, sorry.
Yeah, and derivative of minus 5 is 0. Now, listen. Let's start simplifying everything. What is 2x squared minus 5? I can say the integral of what's 2x squared minus 5? U to the power 6. That part is sorted. What is x dx? You have equation 1. Equation 1, I finished substitute. U to the power 6. What are we left with? We are left with x dx in my integral. Okay? What is x dx? We have x dx, that's du over 4. Are we good? What is x dx? Remember, this is equation 2.
4x? du over 4x, no?
Yeah, du over 4. This is equation. You need to substitute both the equation inside the integral. So now, see
Oh,
this.
yes.
You see this quarter over here, du over 4. You can take it out of the integral or you can keep it inside. It doesn't matter. So I've got quarter u to the power 6 du. Simplify this. Leave the quarter as it is. U to the power 7 over 7 plus c. 4 times 7 is 28. So you got 1 over 28. What's u? 2x squared minus 5 to the power 7
7.
plus c. Yeah.
Plus
And
C,
that's
yeah.
my answer. Now the question is, can I do this on the calculator? No, you can't, because we don't have definite integral. This is indefinite. So that's why indefinite integrals is much more harder than definite integrals, because for definite integrals, you can always verify your answer on the calculator. Right. So I just did the technique of integration, which is called U substitution. Right. Now I want to go back here to trigonometric integrals. Right. And remember, I already integrated in pairs for you. So now how about this? I integrated in pairs. What if I try to integrate singles? If I don't integrate singles in sec x and cosec x, that's not in the syllabus. Let's try to integrate tan and cot. Only those singles. Right. So I want to find the integral of tan x dx. Let's try this out. So what is tan? Put it in
Sinus
terms of
over
sine and
cosinus?
cos. Huh?
Sine over cosinus?
Yeah.
Sine over
Sine over
cosinus?
cos. Sine x over cos x. Now comes the fun part. You see sine x over cos x. There's no forms that we can just go directly to the answer. So we say let cos x equal to u. Always make the denominator equal to u. So you say let cos x or let u equals to cos x. I don't need to put let, okay? Just put a comma and continue with this. Put a comma. I say u equal to cos x. What's du? Du dx, all right? So I put this dx from the bottom, went across. What's the derivative of cos?
Negative sin? Just sin. Yeah,
Negative
just sin.
sign. Negative. Negative.
Negative.
Negative. It starts with a C. Yeah. Negative sine
Yes,
x.
sir.
You have to be precise. You leave out the negative, you're going to lose marks. Right. So negative sine x. Okay. So what is cos x? So I've got integral of 1 over u. What is, so I finished substitute the cos x. I finished substitute equation 1 inside here, right? I'm substituting equation 2. What are we left with? I'm left with sine x dx. What is sine x dx? Negative du. Are we good, guys?
Oh, yeah, negative du. So, yeah.
Now, what is the integral of 1 over u? That is not power rule. That is log rule. What's the integral of 1 over u? Ln u. What's the answer? Negative, because of the negative there. Ln absolute value u plus c. Try to grasp all this
Oh.
knowledge now.
Should we put instead of u cos x? Absolute
Yeah,
value
you
cos
have
x.
to. You have to, yeah. Absolute value cos x. You have to.
Mister, I don't understand how you got negative du. Can you repeat it?
Okay. See, in the integrand, in the integral, we had 1 over cos x. So I said that's 1 over u. What were we left with? Sine x dx.
Sin x dx,
What?
yes.
Yeah, what is sine x dx? Negative du. You need to multiply by negative on both sides.
Okay.
Right, so that's negative du. So take the negative out of the integral. What's 1 over u du?
Negative
Ln
ln u,
absolute.
and then du becomes plus c.
No. Du doesn't become plus c. You are integrating. It's an indefinite integral. How can you say du becomes plus c?
So what does du become in this, in the
No,
negative
du for
ln?
the integral and the du, it means you are integrating with respect to u. That's what the du means. The integral of 1 over u is ln u plus c. You get it?
The integral of 1 over u is yeah, it's ln u plus
U,
c. What happens?
that's it. Nothing happens to the integral, and the du falls out because you are integrating with respect to u. The du doesn't become plus c. That's nonsense. The integral and the du falls out because you are, this here just means that it's like a change in, when you do Riemann sum, this here represents the width, okay? And this here represents the infinite sum. So du doesn't become plus c. It's just the integral of 1 over u. What if I change this to dk? Then this here becomes a constant. You are integrating with respect to u. That's what it means, okay? All right, guys.
Wait,
So
so
we
mister,
are,
instead of
I
having the
still don't
sin x
understand,
dx,
mister.
okay. I want to change this question and I want to ask you, give you an example. Okay. So I want to say, all right, so integral of a times b dA and integrals of, okay, a squared b dA. And the second example I want you to do is integral of, okay, a squared b squared dA and a squared b squared dB. What's the answers here? You are integrating with respect to a. So a is your variable, b squared is your constant, okay? So I'm going to take the b squared out. What's the answer? A cubed divided by 3 plus c. Are we good? That's your answer there. Now what's your answer here? B is my variable. So a squared is my constant. So I'm going to say a squared b cubed divided by 3 plus c. Plus c means it's an indefinite integral. It does not mean that dB becomes c. What is that?
Constant in this case, no?
The plus c means it's an indefinite integral. See, there's no
Oh, yeah.
values here. The plus c means it's indefinite. The plus c means it's indefinite. This here represents that you are integrating with respect to a. This here represents you are integrating with respect to b. It's a notation. Are we good? Do you understand?
Wait.
Yes, sir.
yeah, mister. So we can move variables outside if we're not if we're not integrating with respect to
You
them,
no,
right?
no, no, not variables. You can move constants. It becomes a
Constants,
constant.
okay.
Yeah,
Oh,
constant
a
out
is a
of the
constant.
integral.
A and b are both okay. Okay, I see.
In the first
Yeah,
example,
okay.
a is a variable,
A
So,
b
is the
is a
mister,
variable,
constant.
b is the constant. Okay.
here,
Yeah.
Wait, so I think on top you did something like 1 over 4. And you
Yeah,
moved
I took
that
that out.
outside. Yeah, you
Yeah,
took
yeah,
that out. Okay, so we
yeah.
can
It's a
do that,
constant.
right? After we
Yeah,
integrate the
yeah,
inside. Okay.
mister,
yeah.
here,
Okay.
the minus d became minus, right?
The du becomes minus du, yes, because sine x dx is minus du. Remember, I
So
only need to
negative
substitute.
du, it's the negative sign in ln u plus c, right?
No, no, negative du means negative 1 times du. See, this is what it means. You see that negative du means I can take the negative out of the integral. You have to understand this. Come on, man. Right, so take the negative out of the integral, just 1 over u du. Okay?
Yes.
Right, so khalas now. Now, after this, just integral of 1 over u is ln u and then plus c because it's a indefinite integral. That's why we're adding a plus c. Okay? Now, great, guys. So
You're gonna
we
explain it to
found,
me tomorrow in school. I don't
yeah,
understand.
yeah, okay. Next one. Look at this. See, we know laws of len, right? So you can take this negative 1 to the power. So that becomes len cos x to the power negative 1 plus c. And what's cos x to the power negative 1? 1 over cos x, all right? So that becomes len sec x plus c. Are we good?
Oh, yeah. Yeah, sir. Yeah, great. This one I wanted to ask, sir.
Yeah. So that's the answer of integral of tan x, len sec x plus c. Are we good, guys? Excellent. All right, so what about cot? Okay, so you're going to do a similar thing with cot. I'll put that in your homework exercise and you can work with that, right? Now, guys,
But
I
it's
had some
cosine over
examples.
sine, yeah?
Yes, cot is
Cosine.
cosine over
Cosine.
sine, yes. So you're going to make
Yes.
sine x equal to u and solve it in a similar way.
So
I'll
do
put
we
that
have
in your
to
homework.
do we have to make u the denominator if we're doing this kind of thing? Do we always have to make it the
Yeah.
denominator?
It's like a
All
rule.
in
The
there.
denominator part must be equal to u. Unless you can factorize
Okay.
and simplify, then that will be
Yeah.
great.
Like if
Right
it's a
now,
pair or something or a
yeah.
triplet. Like,
Look, guys, I did have some examples for you to solve, and I'm going to put it down here. And we're going to try and solve them as quickly as possible. I only have 6 examples. Try to solve them in like not more than 10 minutes, right? So let's see. Find the general indefinite integral. So we want to find the integral of this. It's like mixed problems, all right? So integral of 8x to the power 5, integral of x to the power 5. Remember the variable is x, so great. Right, so that just works out perfect. There's no confusion here. So that's just going to be 8 x to the power 6 over 6 plus 3 is cosec squared a pair. Sec.
no,
Yeah,
One
it
Mr.
is
over
a pair.
time.
Man,
over
Shouldn't
time.
shouldn't it be negative? Oh wait, no, it can be. It'll be negative
Hey,
cosine.
yeah, it's
Negative
negative
cot.
cotan.
Negative cot.
Negative cot because it's a pair.
Mhm.
I told you
Yeah,
integrating
it
in
is a
pairs
pair,
here.
but I was confused like the
Yeah,
negative.
yeah, there's it. Integrate
We
in
can move
pairs.
the
What's it?
negatives around, right?
Yeah.
Okay.
So this one is a pair. We integrated in pair.
Yes.
Yes, it
So
would be
watch here.
negative cot
Yes, it's
x.
good. That's negative cot x. Let me put the rule down for you here. Please don't ever forget this table. It's very useful for differentiation and integration. So that's negative cot x plus c. So my final answer is 4 over 3. You have to simplify. X to the power 6, negative 3 cot x plus a general constant. Are we good? So you say indefinite integral. Let's move on to the next example. So we want to evaluate the sine theta over cos squared theta. Now the problem is, do we make, okay, obviously we need to make the denominator equal to u. So you say u is equal to cos theta, okay? So we are differentiating with respect to theta, right? So there's du and the d theta from the denominator, I'm taking it over. What's the derivative of cos? Negative sine theta,
Negative
okay?
sign, yes.
Right. So now there, we got integral of what's 1 over cos squared. So that's 1 over u squared. What is sine theta d theta? That's negative d theta, right? Negative du.
Yes, negative.
Right. But now this is not Len form. This is power rule. Okay? Negative u to the power negative 1 over negative 1 plus c. Now, negative 1 and negative cancelled out. You just got 1 over u plus c. What is u? U is
Is
cos
negative sin.
cosine.
cosine theta.
Just
U is
cosine.
cosine theta.
Cosine.
So
Yeah.
it's gonna
Cosine
be
theta.
secant plus
Secant.
x. Sec
It's
theta plus x.
second plus c. Plus c.
Yeah, good.
Mister, I sent you a
Yeah,
question. See.
I will check it at the end. Wait, let me finish my
What?
problems, and then I will have a look at your
It's a
questions.
good question what I sent you. You're gonna like it.
Great. Right, question 3. I want to solve this basic indefinite integral. Obviously, you can check this answer on your calculator as well. But let's check this out first. We're just going to integrate. So you can say x to the power 5 over 5 minus 4 x squared over 2. And we're substituting from 0 to 2. Right, so if you put 2 inside, you're going to get 2 to the power 5 over 5, which is 32 over 5. 4 and 2 cancel out. If you put 2 there, you're going to get 8, okay? Will I get 8? 2 times 2 squared. Yeah, 8.
Yeah. that is
Subtract
8. Mister, it'll be a
0.
negative.
Correct.
It'll
That's
be a
fine.
negative number.
That's
That's
fine.
Okay.
Yeah. It doesn't
You
mean
get
what does,
negative 8 over
There's
5.
negative 8 over 5.
remember I said finding the area under the curve. Sometimes in physics it means displacement. What's the answer? Negative?
Negative 8 over 5.
Yes,
Negative 8.
negative.
You can check this. You can check this on the
Mhm.
calculator, right? Next one.
Mr.
Good.
If we want like an area value that's valid, we just take the absolute value, right?
No, you have to check what area are you looking for. Are you looking for the total area? Example, if this here
No, like
represents
in
the
this case
okay,
from 0 to 2.
right, excellent question.
Thank
And
you.
I like that question because look at this. If you want the actual distance, assuming that this was the velocity function, right? Assuming that this was velocity, right? If this was velocity and the area under this graph will give me the, what you call, the area under this graph will
Change.
give me, yeah,
It'll
it
give
will
you
give me
acceleration.
the, no. The area under this graph, no, you antiderivative, it'll give you the displacement, the area under this. So the displacement will be from 0 to 2. But now, if you're looking at the type of function, you have to kind of like sketch the function over here in order to. So what this negative is giving you is actually the net, is giving you the displacement, the net change. Okay. So this is
Oh, so
giving
it's
you a
likely it
this.
moved backwards, right?
No, there was like a positive
Yeah,
displacement
so
because you went
positive
forward and
dips.
then you
Yeah,
came back. Yeah.
yeah.
You just switch direction. As a
You
result,
switch
that's a
direction.
displacement. Yeah.
Okay,
So that's
I
what
see.
it represents.
Okay.
But if you want to find the speedometer reading now, if you want to find the actual distance travel, then you have to integrate piece by piece. You have to integrate piece by piece. Example, you won't be integrating, you'll be integrating from 0 to 2. No, because there's x-intercepts here somewhere. X to power 4 minus, you're going to get x cubed minus 2. So you're going to get cube root of 2. You have to integrate like that. You see, you have to look at all the x-intercepts. What's the x-intercepts of this function? Because you
Y
remember,
equals
you
to
find,
0.
let's call it f of x. Yeah, good. X to power 4 minus 4x, make it equal to 0. Remember, this is just an addition question that is one asked. Right, so you take out x as a common factor, you're left with x cubed minus 4 is equal to 0, right? So you're going to get x is equal to 0, or x is equal to the cube root of 4, which is approximately equal to shift cube root 4, which is approximately equal to 1.5874. So if you want the actual area, if you want the actual displacement, not displacement, if you want the actual distance, remember this here, if that was a velocity function, then this will be the displacement, right? And if this was the, yeah, now if you want to find the distance, remember, you got many x-intercepts. So you remember you're starting at 0, right? And then you got 1.5874 and you're integrating right up till 2. So you need to go integrate the function from there to there. And you need to break up the integral and integrate from there to there. Okay? So you're going to have two integrals to find the distance. If this was a, so to find the distance, you need to say this.
Mister,
Yeah.
why can't we solve using complex replacement?
No, you can't. We're not using complex numbers here.
Mister, well, it's way easier.
1.5 we had when we're doing AP calculus is only application problems. We don't work with complex numbers. There's no complex numbers anywhere in AP calculus. You show me an example that has a complex
Euler's
number,
formula. Euler's formula.
but we don't do it. That's complex analysis. Okay, so minus 4x dx plus integral 1.5874 to 2 of x to the power 4 minus 4x dx. You're going to solve it like this. And you have to take the absolute value as well. You have to take the absolute answer because you are solving for distance, okay? You have to split the integral
Positive
in two
value.
parts. Yeah. Because remember, distance is always absolute. If you're getting a negative answer there, you're going to have the same story. So you have to take the absolute distance. Right, so you're going to solve it like this on the calculator and you will get a different answer, totally different answer. Okay? Because now you are observing your odometer reading on your car. because we are finding the actual distance. Okay, guys? That is, just solve this now. It's easy. Right, let's look at the next example. We're going to integrate from 0 to pi of 2x. So that's x squared, right? So 2x squared divided by 2 plus 5. What's the integral of cos x? That should be simple. That's basic integral.
Negative sin. Negative sign.
Derivative.
No, sine x plus c.
Just sign, just
Sine-
sign, just sign.
Just
Oh,
sine x
just
plus
sine.
c.
Yeah, sine x. No plus c because it's definite integral. Okay.
Yeah.
Now remember pi is 180 degrees. Let's take the 2 out, but you have to work in radians. So you're going to say this is pi squared. What is sine of pi? Thinking about the graph.
Isn't it?
0, right?
Sorry, zero.
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 0.
0, 0, yeah, 0.
Right. Subtract. If you put 0 there, you get 0 and 0. So the answer is just pi
Yeah.
squared.
That's pi squared.
Okay.
Okay.
Right. Let's look at 2 more examples. It's very important we do these examples because look at example 6 is something application, and that's the type of example that you need to focus on in AP calculus because you only get application problems for integrals and differentiation. So application is very important, right? Let's see. We got something like this. How do we solve something like this? To solve something like this, put it in power form and split up each one, okay? Let's put this in power form. So that's t cubed. What is this? T to the power half plus 1. 3 over
Half
2
plus 1, yes.
plus 5 divided by t squared dt. Now split up each one. T cubed over t squared, t to the power 3 over 2 over t squared, like that. Over
Then
t
5 over
squared
t squared.
plus 5 over t squared. And now put it in power form. T minus t to the power negative half. Okay. 1.5 minus 2 is negative half plus 5 t to the power negative 2. And this is just power rule, right? So that's t squared over 2. Add 1 to the power here. T to the power half divided by half plus 5 t to the power negative 1. Add 1 divided by negative 1 from 1 to 4. So simplify the inside and then substitute 4 inside, all right? That's half t squared. 1 divided by half is 2. And t is square root of t minus 5. And bring the t to the power negative 1 down. It's easier to substitute into this than to substitute into this, right? Now substitute 4 inside. 4 squared is 16. 16 divided by 2 is 8. 2 root 4. 2 times 2 minus 4.
4.
Minus 5
Minus
over
5 over
4.
4.
Yes, subtract. Substitute 1 here. Just half minus 2 minus 5. You try to do all this on the calculator. That's 4 minus 5 quarter. That is 7 plus 7 minus 2 quarter is half. See what I did here? Minus 2 minus 5 is minus 7. So I added 7 because minus minus. And minus half is minus 2 quarter. So I can add all the numbers up and all the fractions up. 4 plus 7 is 11. 5 quarter minus 2 quarter is minus
3 quarter.
minus
3
7
7
quarter.
quarter.
Oh, yes,
And then
7 quarter. Sorry,
44.
yeah.
11 over 1.
Minus 30. No, not minus. 37 over 4. 37 over 4. Yeah.
Yeah, 37 over 4. Yeah, great.
9.25, right?
9.25. Around, yeah.
Great. Yeah, not around
Yeah,
exact.
36 and then 1 quarter. Yep.
9.25? Great.
Yep.
So you can put this into the calculator as it is with this square root and stuff, and you
we'll
should
get that
get the
answer,
answer
right?
of 9.25. Yeah.
Okay.
Right, next one. Last example. I have to do it
Last
because
example.
it's
So
application
practical,
and
right? Okay.
it is a practical problem, and this is the type of problems that you must expect in AP Calculus exams. But obviously,
Ghazali,
with
when
more
I'm done, I
complicated functions.
solved 4 using a different way. See,
Why? This is so easy.
Mister,
The
no,
method is
number
just one, 2
4.
steps.
No, number 4, I solved it using the 4 series.
Oh, no. Don't use all that. That's mass 2 and stuff, man. Leave
And
that
Mister,
out.
I used the Riemann zeta symbol.
All right. Don't do all this funny stuff. You're going to
Why?
Ramanujan's theory and stuff. All right, guys. A particle moves, so its velocity is, what is this? Velocity function, right? It's particle physics, all right? So that's a velocity function. If I integrate a velocity, I get displacement. Remember what I told you. If you differentiate displacement, you get velocity. You differentiate change in velocity over change in time is acceleration. If you integrate acceleration, you get velocity. If you integrate velocity, you get displacement. So find the displacement for 0 to 3. Displacement easy. So A from 0 to 3, so you're going to say displacement from 0 to 3. It's like kind of saying S of 3 minus S of 0. Which is basically integral 0 to 3 of t squared minus 4 dt. You're integrating velocity, okay?
Calculator, right?
You can use a calculator, but it's easier to show the working because
T cubed over 3.
if it's a free response question, you got to write. If it's a response question, you got to write
Mister, you won't
3
get this
minus.
free response.
No, I always do the question as if it's free response questions, right?
Oh, yes.
I can't do multiple choice and guess the answer and show you cheating method. I have to show you the forward method. Right. Now, if you substitute 3 inside here, you will get 27 over 3, which is 9. Substitute there. 9 minus 12.
12 minus
Yes.
3.
Minus 3 meters.
Yes.
In other words, it's going in the opposite direction, which is correct. Okay, this is 9 minus 12 and then minus 0 here. Oops. Remember to substitute the lower bound and subtract 0. So you remember that maybe the particle went forward first and then came backwards. Okay, that's why it is minus 3 meters. Now B.
One
Find the
question before, sir.
Yes.
Please, sorry.
Oh,
You see, find the displacement for 0 is less than or equal to the 0. You see, if it will be no equal, what you will do in that case?
same. Because it's a continuous function, you will include it. Whether it's including or not including, it means the same thing because of continuous function here. It's not discontinuous.
Okay.
Remember, t squared minus 4 is what's the domain of t squared minus 4? All real numbers. T is an element of all real numbers. So it's always continuous. There's no break-in point in the graph.
Okay. Understood.
Yeah, unless the function is 1 over t, then you got a problem. You can't substitute 0 now. You have to say from 0 to 3 without the including. Okay?
Yes.
So,
Great. Okay.
sir, great. Find the distance traveled. Now, for distance travel, you have to make v of t equal to 0 and check. That's t squared minus 4 is equal to 0. So now you got t plus 2, t minus 2 is equal to 0. So t is equal to negative 2, which is not applicable. Time can't be negative. Or t is equal to 2. So you got a break-in point in the graph at t equals to 2. So you got to integrate like this. So there's 0 here, there's negative 2 here. So all this is negative time. That's not applicable. 2 is applicable. And 3. So you got to integrate from 0 to 2. And you got to integrate from 2 to 3. So you're going to have 2 integration for distance, as I mentioned before. Okay. So the distance is equal to integral from 0 to 2 of what? 0 to 2 of the function t squared minus 4. Plus 2 to 3 of t squared minus 4 dt. And taking absolute value. Okay. Because you are calculating an actual distance. It's like distance is only moving forward, like your speedometer in your car, right? Sorry, the odometer in your car.
Sure. What is the question again? The distance between what?
The distance from 0 to 3.
Oh, okay.
But we got a breaking point. We got like the graph is changing direction at 2.
Yeah, it's a
Because
point
T's,
of inflection.
no, the graph is changing direction at 2 is
It's not changing signs. Right. My bad.
right. So now let's look at this. So this is t cubed over 3 minus 4t. That's what we had, right? 0 to 2 plus same thing, t cubed over 3 minus 4t from 2 to 3. So substitute 2 inside here. You're getting 8 over 3. 8 over 3 minus 8. Okay, remember to take absolute value minus 0. That's out. You get it? That's the reason why you do an absolute value.
Yeah, right.
And then the next one, because you're going to get a negative answer here. Substitute 3, you're going to get what it was, 9 minus 12, which is negative 3. And subtract the lower value. If I substitute 2, I'm going to get 8 over 3 minus 8 and absolute value, the whole thing. So what's 8 over 3 minus 8 absolute value? That is 24 over 3.
Which is 8.
18 over
no,
3.
8. Yes, 18
Sorry. No, not 18. 16 over 3. That's 24 minus
16,
16 over 3. Plus, what is this now? Minus 8 plus plus 8. Minus 3.
5,
Yeah,
5,
because
it will be 5.
no. I still need to minus 8 over 3 here. So it's going to be 5 minus 8 over 3. Yeah. 5 minus 8 over 3.
Wait, how did you get 5?
7 over 3.
Isn't it
7 over
minus
3?
3?
No, negative and negative is positive.
Okay, so
8
16
minus
over
3 is
3.
8 minus 3 is 5.
Oh, okay, yeah.
Because remember, I still need to
8
simplify the whole
minus
thing and then
3.
take absolute value. So that's 15
Okay,
over 3
7
minus
over
8,
3.
that's 7 over 3. Yeah,
7
absolute
over
value
7
is
over
7
3.
over.
Yep.
So my final answer is 7 plus 16, 23 over 3
23 over 3. Okay.
meters. Okay,
That's the distance?
that's the distance. Yeah.
Okay,
Okay, guys.
cool.
Great. Yeah, so remember to take a positive value there and positive value there. You add the two distances, and that's your answer. Displacement is just.
See my question.
Okay, wait, let me end the session and then I'll look at your questions.